Hello everyone, I'm Linda, a digital character generated from tens of thousands of neural network iterations. I'm a volunteer of Themed Entertainment Association, which is known for TEA. It's a global organization including over 1,000 excellent creative companies such as Universal and Disney. We have many online and offline mixer activities sharing the latest cutting-edge technologies to empower film, animation, game, education, and other content-based productions. Welcome to join us. By using generative adversarial networks, everyone can create a virtual character like me. Starting today, I will share with you how to implement it. There are currently two main technical pipelines to generate a virtual character. The first pipeline is to create 3D model of the human face and body, then use motion capture system to capture facial and skeleton key points, then map these key points to the 3D model to generate animation. In this tutorial, I'm going to introduce the second pipeline, which uses end-to-end neural networks to directly generate virtual characters' photorealistic videos. This pipeline contains many neural networks. The main networks are NVIDIA StyleGAN and video-to-video. NVIDIA has just updated them to StyleGAN 2nd and the few-shot video-to-video last year. Video-to-video network has the ability of cloning facial emotions from other videos and generating new videos according to a character's single image with photorealistic quality. The benefits of this technology are: number one, you don't need to model. Number two, no depth camera is required. This means that everybody can generate virtual characters videos with simple device and no post-production work. NVIDIA's few-shot video-to-video neural network requires two types of input data. One is a still image, such as a photo of a virtual character's frontal face or whole body. This photo can be generated by another neural network called StyleGAN, which I'm going to introduce later in this video. The other input data is the motion data of the face or the whole body of each frame with the formats of dense pose and open pose neural network outputs. These two neural networks are mainly responsible for capturing the key points of each frame of the face and the whole body from video or a web camera. Feed the above two types of data into the few-shot video-to-video neural network, it can directly generate the video results. Because it may involve the intellectual property of portrait rights, most people would like to create their own customized characters. Today, I'm going to tell you how to use StyleGAN technology to generate my virtual faces and body. You can find the StyleGAN 2nd GitHub link below this video. My face is generated on the basis of NVIDIA's pretrained model, plus some extra transfer learning. The easiest way to reproduce this process is to use your favorite star's photos and continue training the pretrained network, and eventually the neural network will learn to draw a photo same as input one, or a mixed blood face between the final one and the initial one. Creating the image of a body is more difficult than the face. There is no tutorial on generating a human body on YouTube before. It is because the manifold of the body is quite different from the face. Current algorithms are not ideal for non-convex manifold surfaces, especially those meshes with holes. These are non-convex manifold surfaces or hole-like body images that often confuse the StyleGAN discriminator. The posture of touching the leg or head with hand, holding or crossed hands, and the arm akimbo. The neural network had no idea about the hierarchy and the total amount of these body parts. Do you remember the backpropagation process of neural networks I talked about in the last tutorial? For many neurons, they have the same activation functions, just like neurons are forming different groups by different chain rules, which forms the special transformations of the limbs in the space. But the premise of currently expressing the body posture is a correct grouping of the groups. Our input image data set often has very sparse body posture. Each posture may have only a few pictures, which results in the neural network unable to correctly reshape your chain rule hierarchies, resulting in very low learning efficiency or wrong body part groups. This is my training process, as you can see after seeing the above pictures. The neural network didn't figure out how many legs and arms a human body should have. Sometimes the neural network thought that the legs are arms extension parts. There is always a small part of connecting the hand and the leg. There must be somewhere in the neural network exists a separate activation function responsible for this connection. And because the wrong connection of these neurons, when the input images are sampled with different body poses, the body parts related neurons cannot express the new postures correctly. You might want to train the neural network with pictures of simple poses, but you will not train a robust neural networks by this way. The training process is often accomplished by several network explosions, including gradient explosion and activation explosion. What you see now is a network explosion. When the discriminator of the GAN neural network tells the generator to generate the wrong body part, the generator will try to fix the error by method of dimensionality reduction in the future iterations. It modifies the activation function and the connected neurons. When the discriminator is not smart enough at the time, it will send the wrong information to the generator, causing the generator to backpropagate incorrectly, which eventually leads to a network explosion. In this case, most neurons lose the ability to produce valid information, and only a small number of neurons are left to work. This is why after each explosion, generated results will have the same aspect whatever your random input vectors are. How can we train the neural network correctly? My experience is switching datasets during training, and you might need a little bit luck because switching early or later will lead to network explosion as well. When you find that the gradient slows down during training, such as when a neural network repeatedly tries to generate a certain body part, it's time that you switch to other dataset. My current training has gone through two phases. Phase number 1, as much data as possible for the neural network, including various faces, body poses, camera positions, and focal lengths. The model trained in this way is more robust and more general. When encounter network explosions in the future, it is possible to repair itself. I once tried to start training with the simplest T-pose 3D human body model, and as a result, I quickly encountered a network explosion, and the model can no longer get fixed itself. It is because the dataset for neural network training is too simple. When you notice that the efficiency of the phase 1 training becomes lower and the body part is obviously wrong, this is time to start phase 2 training. I used a fashion video dataset from UBC Computer Vision Lab for this stage of training, and its benefits are 1. No background environments, so that the neural network can focus on human body generation. 2. The camera position and the focuses are fixed, and people are basically in the middle of the screen. This escaped the affine transformation learning of the neural network. 3. The posture of the person is simple. Standing posture, hand dropping. We can see that in the previous training, the errors were mainly happened on arms and hands. These simple poses allow the neural network to quickly learn to separate those body parts. 4. There are continuous spatial transformation between video frames, which allows the neural network to get dense data input of each feature. From the video being played, we can see that in phase 2, the neural network encountered several network explosions, but it could fix itself after the explosion. Finally, a more accurate human body generator is obtained. Notice that if you start phase 2 training too early, you may encounter an irreparable network explosion like this video, or generate a distorted space which prevents the neural network from finding the correct gradient. When phase 2 is completed, you can continue training by increasing the complexity of the dataset in terms of depth of field, background, character poses, and closing style. But it's better to increase the difficulty gradually. The training of the neural network is like driving, switching the dataset constantly, just like manual transmission of the car. Through manual training, we drive the neural network, avoid those traps in time. This is my training experience, and I hope you found it helpful. And you are welcome to share your experience in the message area below or revise my point of view. In our next video, I will share with you how to train the video-to-video neural networks. So, bye for now.